Hi to all. Today's topic is power in AC LCR series circuit. How we can calculate the power in AC circuit. We know in DC circuit how we will calculate the power. In DC circuit, the voltage and current value almost remains constant. It is independent of time. Then the power formula in DC circuit is only voltage into current. But in AC circuit, this voltage and current values are varies with the time. Then how we can calculate the power consumed in certain circuit in certain time? Then for that, we have to use some another formula, right? And there is some method is there to calculate the average power consumed in certain circuit. Then for the purpose, what we have to do, first here AC source voltage, AC source we are applying to the LCR circuit. Then I want to find out the average power consumed in LCR circuit. Then for that purpose, here the source voltage is V0 sin omega t, where V0 is the peak value of voltage. The peak value of current in this we can consider as I0. Now here the instantaneous voltage, instantaneous AC source voltage, AC source voltage, right? Instantaneous means voltage at any instant of time. Instantaneous AC source voltage is V is equal to V0 sin omega t. Instantaneous current, current at any instant of time. Actually in AC, the voltage and current values varies with the time, right? Instantaneous current formula is I is equal to I0 sin omega t or plus phi or minus phi in the LCR circuit. Okay, we know that one already. Now I want the instantaneous power. Instantaneous power. Instantaneous power means the power at any instant of time. That is, it is the product of voltage and current. That is, voltage is V0 sin omega t and the current is I0 sin omega t plus phi, where phi is the phase difference between the current and voltage. Then we will get the power function as V0 I0 sin omega t into sin omega t plus phi. We rewrite this equation, that is the power is equal to V0 I0 sin omega t plus 5 into sin omega t. Okay, first I am writing this. This is equation 1. Let us consider this is the power equation. This power is depends upon the time, but I want the power consumed in AC circuit. Okay, that is average power consumed in one complete cycle is called as power in AC circuit. Power in AC circuit. Yes, how to calculate the average power consumed? Average power consumed in one complete cycle. One complete cycle means one complete cycle, the time taken is called as time period. In that time period, how much power consumed, that average power I am going to find out. Okay, let us see the duster. Okay, let us see how to calculate the average power consumed in one complete cycle. Average power in AC circuit, the power is varies with the time. I want to find out the average power. Then for the purpose, the average power is equal to, there is one formula is there in the mathematics. The average of certain function we can find out like this. That is, the average value of certain function is, right, average value formula is in certain time, if you want to find out 0 to t, f of t dt by 0 to t dt. In certain time, the average value of function f of t we can find out like this. Then average value of power I want, then for the purpose we have to take the function is the p of t dt, power, average power I want to find out. Integration 0 to t f of t dt. Here the function is the power function. Here average value of f of t is the f of t we have to write. Average value of power p of t we have to write dt. And this the limits in one complete cycle we have to calculate 0 to capital T by 0 to capital T dt. This is the formula to find out the average power. If you want to find out the average of certain function in certain period of time, then we have to do the integration, okay, f of t function of time, function in time dt by 0 to certain time, integration 0 to t dt. This is the formula, and then we have to use this formula at here. Let us substitute the values. Then for the purpose, p average is equal to average power 0 to t p of t we know v naught I naught here from equation 1. There is a sine of omega t plus 5 into sine omega t by this integration dt is t, that if you substitute the limits, then we will get the capital T. Integration dt is t, the limits are 0 to capital T. When you substitute the limits at here, we will get capital T, right? This capital T I will write outside, 1 by capital T into this v naught I naught also I will write outside, v naught I naught integration 0 to capital T. The remaining is sine of omega t plus 5 into sine omega t we write. Okay, what I did it here, small t limits, if you substitute in place of small t we write capital T minus 0. Right, first in place of small t capital T minus, in place of small t lower limit 0, t minus 0 we will get here t, and this v naught I naught is a constant that we are writing outside. Then integration this one we got, I want to multiply with 2 and divide with 2, right, this equation. Then we will get average power in AC circuit is v naught I naught by 2t into integration 0 to capital T to sine omega t plus 5 into sine omega t I am writing. Okay, you use one mathematics formula, 2 sine A sine B. Right, what is that formula? 2 sine A sine B formula is cos of A minus B minus cos A plus B. This is the mathematics formula. You have to use it here, where something is A and something is B we have to take. And let us see here, this is the formula. I will give the one in the box. We will substitute in this. Then how you will get the formula, right? Next equation what you will get, the average power is equal to v naught I naught by 2t into integration 0 to capital T 2 sine A sine B. This we will take as A, this we will take as A, and this we will take as B, right? Then what you will get, 2 sine A sine B. Then first of all we have to write cos of A minus B. Okay, and something I forgot it here, dt we wrote the p of t function at here, but into dt is there, right? Into dt, this is missing, into dt is missing, into dt, right? Okay, let us write here 2 sine A sine B is the cos of A minus B. A minus B you can do omega t plus 5 minus omega t. We will get omega t cancel, then we will get the cos phi minus cos of A plus B. You have to add these two, omega t plus phi plus omega t. Then we will get 2 omega t plus phi we will get into dt, right? This is the function. And let us go for the one more step, right? That is p average is equal to v naught I naught by 2t into integration, we have to multiply, right? integration cos phi dt minus integration 0 to capital T cos of 2 omega t plus phi dt we have to write. Okay, just what I did in this step, I multiplied with the integration, I multiplied with the dt, then we will get this step, right? And I will continue now what you will get in the next step, I am going to derive the formula for the average power, right? And now you take the screenshot, and note every point, then I will continue after the rubbing. Okay, let us see here. This is the equation. I am going to simplify it here. Then for the purpose, P average is equal to, we will get like this, V naught I naught by 2t into, what's remaining it here, integration cos phi dt. Cos phi is a constant, we write outside. Cos phi integration 0 to t dt we have to write, minus 0 to t cos 2 omega t plus phi dt, right? Okay, as it is I wrote the second equation, as it is I wrote. But in the mathematics we know that this term, the integration of this one is 0, right? You can do if you want, right? But it will be give some more steps, right? And I am going to write directly, okay? And if you want, you can try in rough notes. Integration dt is t, okay? The limits are 0 to t, minus this term total is 0. Then finally what you will get, the average power in LCR circuit we will get is V naught I naught by 2t into cos phi into, limits we have to substitute. If you substitute the limits, capital T minus 0 we will get, right? Then you will get like this, that is the average power is equal to V naught I naught by 2t into cos phi into t, this will cancel, and finally we will get one equation, that is average is equal to half V naught I naught cos phi we will get, okay? And this we can also write like this, V naught by root 2 into I naught by root 2 into cos phi. We know that V naught by root 2 is VRMS, right? This is the VRMS, and this is I naught by root 2 is IRMS, and this is the cos phi. This is the formula for the average power in LCR circuit. Okay, generally what is VRMS here? RMS voltage. VRMS is the V naught by root 2. It's can say that it is the RMS voltage. What is IRMS? RMS current. RMS current. What is phi? Phi is the phase difference. Phase difference between VRMS and IRMS, means the angle between the IRMS and VRMS. Phase difference is nothing but if it is IRMS and it is VRMS, then the angle between them is the phi. Okay, phase difference between the voltage and current. This is the formula for the average power. That means here extra cos phi will comes. In the DC only power equal to voltage into current, but in AC the power equal to voltage into current into cosine angle between the voltage and current also we have to take. Okay, right, this is the major difference. And the next I am going to explain some cases and what is cos phi, that I am going to explain, and you take every point. Okay, you note in the copy. Let us see here. I am going to explain something. What is cos phi in this? Cos phi. We got the average power formula, right? And what is cos phi in this? Cos phi. That is called as power factor, right? Power factor. Power factor. Okay? Right. What is power factor? Cosine angle of phase difference means angle difference, phase difference between voltage and current is called as power factor. Okay, power factor. And this power factor is nothing but power factor is equal to power factor which affects the power in AC circuit, that is the cos phi. Okay, and from impedance triangle, right, power factor equal to cos phi. From impedance triangle we write something, right? What is impedance triangle? Do you know in LCR circuit? From impedance triangle we write the cos phi formula, right? For example, this is XL minus XC. Okay, impedance triangle. This is Z, this is R, right? This is phi. Okay, and now let us see, or otherwise you can take this one is like this also, there is no problem. You take like this also, there is no change. This has XL minus XC, and this is R, and this is Z, and this is phi. No difference, right? From impedance triangle, power factor we write, power factor formula we write. Power factor is equal to cos phi. What we write cos phi from this? Adjacent side by hypotenuse means R by Z we write. R by Z we write. Okay, right? This is the power factor. And now power factor from equation 2 also we write. From equation 2, right? From equation 2, this average power is called as true power. Okay, average power is called as true power. Okay, and here VRMS into IRMS is called as apparent power. And then we will write like this, that is the true. From equation 2 we write like this, right? Cos phi is the power factor. Cos phi is the power factor. Then what we write? Right? From equation 2, true power is equal to apparent power into power factor, right? This is the formula. Okay, this is about power factor. This power factor, it is a ratio between the resistance and resistance. It does not have any unit. Okay, unit of power factor. Unit of power factor. Right? What we write? Tell me. No unit. Right? Okay, this is about power factor and power factor formula. Let us see some cases in this power. Okay, let us see the case 1. Okay, I am going to explain some cases in the power. And for that, first we write the formula for the average power or the power in AC circuit, right? What is the power formula for the power in AC circuit? Power in AC circuit. How to calculate the power in AC circuit? That formula is Vrms into Irms into cos phi. Actually the AC voltage is changes with the time. That's why we will take the RMS voltage as AC voltage, RMS current as AC current. Now let us see the cases. The first case 1. Case 1. In case of resistive circuit, what is the average power? A resistive circuit. If the circuit is resistive circuit means it consists to only resistance, right? In case of resistive circuit, we know that, right? In case of resistive circuit, in this case of resistive circuit, we know that the phase difference between the current and voltage, how much? Current and voltage are in the same phase, right? The current is right side and the voltage also same. Voltage across resistance are in the same direction. The phase difference is 0 at here, right? Phase difference is 0. When phase difference is 0, then what about the power factor? Power factor, yes, the power factor is the cos phi. It is the 1, right? Cos 0, 1. Then average power, what happens? Average power, its formula is Vrms into Irms into cos phi. Cos phi is a 0, right? Cos 0 value is 1. Then we will get the average power as Vrms into Irms. This is RMS voltage and RMS current. If you want to write in the peak value of current and peak value of voltage, you can express also. There is no problem. That we write like this. That is Vrms is V0 by root 2. Irms is I0 by root 2. Then we write half into V0 I0. This is also average power in resistive circuit. Next, second one is the inductive case 2. Let us see inductive or capacitive circuit. Inductive or capacitive circuit. That means inductive means its circuit consisting only inductor. Okay, the circuit consisting only inductor. If the circuit consists only inductor, right? This is AC source. In this case, if the applied voltage and current, if you draw the graph, we will get the current as this side, the voltage as this side, voltage across the inductance. This is 90 degree lagging. Current lags the voltage by 90 degree in anti-clockwise direction. This is in case of, we write here the phase difference is 90 degree. In case of capacitive circuit, if you go for the capacitive circuit, this is a capacitor and we are connecting to the AC source. In this case, right, what happens? This is the current and this is the voltage across capacitance. Voltage across capacitance means V suffix C. Okay, here also the phase difference is 90 degree. That means either in inductive or capacitive circuit. Through the phasor diagrams, we know that, right, the phase difference is 90 degree. Then what happens to power factor? Yes, the power factor is cos phi. That is the cos 90. That is 0. Then average power, what happens? Average power is equal to, we write Vrms into Irms into cos phi. But the average power is equal to, Vrms is what? Vrms is Vrms and Irms is Irms. Cos phi is the cos 90 we write. Okay, cos 90 is 0. Then we will get the average power as 0. Average power as 0. That means inductive or capacitive circuit are said to be, right, wattless circuit, they cannot consume any power. They cannot consume any power because we know that cos 90 is 0. Okay, it cannot consume any power. During that some current passes, that current is called as wattless current because there is no consumption of power by that current. That's why the power consumed is 0, and that at that moment the current is called as wattless current. If average power is 0, if average power is 0, then current is called as wattless current. At that moment the current is called as wattless current. It cannot consume any power. Okay, and the next, let us see the case 3. LCR resonance circuit. LCR resonance. Okay, right. In LCR circuit, if you see that, if you draw the diagram, in that inductor, this is only resistor, this is inductor or capacitor, this is 3 are there. If 3 are there, we write like this. Okay, and this is the VL minus VC, and this is the current, and this is the phase difference, the net voltage. This is the phase difference between the net voltage and current. And this is also VL minus VC, and by I, or impedance triangle, if you draw this, we write like this. This is the resistance, or this we can also write voltage across resistance, and this is the XL minus XC, and this is a Z, right, from the impedance triangle Z. Okay, in LCR circuit we write the average power as, right, average power we write as Vrms into Irms into cos phi. This formula we already derived in LCR circuit. In LCR circuit, what is cos phi in this? Already we know, R by Z. But at resonance, what happens? At resonance, we know that condition is XL is equal to XC, and Z should be minimum. The current should be maximum. Then if XL is equal to XC, what happens to the power factor? Then we know the power factor is cos phi equal to R by Z, but the Z is under root Z formula we know, under root of R square plus XL minus XC whole square. If you substitute XL as XC, because both are equal in the at the resonance, then we will get the cos phi as R by R we will get, because XL is equal to XC. They will be cancelled with each other. At the resonance they will cancel. When they will cancel, we will get R in the denominator, then we will get the cos phi as 1. Then what about the average power? Right, then we will get the average power as Vrms into Irms into cos phi, that is equal to Vrms into Irms. Right, it is same as what? It is same as resistive circuit, Vrms into Irms. Right, these are the some important cases that I explained in power concept. Now I am going to explain little definition and one formula, and after that I will close today topic. You take the screenshot and note it. Okay, let us see the wattless current. What is wattless current? Means watt is the unit of the power. Powerless current means if the average power consumed by a current, if the average power consumed if the average power consumed by a current in circuit is zero, then such current is called as powerless current. That means wattless current. That current will not consume any power. Okay, let us see which is wattless current and what is the formula for the wattless current. This is the RMS current. Okay, you see this is the RMS current and this is the RMS voltage and the angle between them is phi. The power in AC circuit we can define like this. Okay, the power in AC circuit, how to define? Power in AC circuit is the product of RMS voltage and VRMS into IRMS cos phi. I will classify this IRMS into components, two rectangular components. IRMS divided into two components. One component is along the direction of the voltage, that is IRMS cos phi. Other component is perpendicular to the voltage. Okay, and this is IRMS sin phi. Okay, now this IRMS cos phi and IRMS is split into two components, two rectangular components. This component is attached with the angle, that's why you will get by multiplying with cos. Okay, another is sin. And this IRMS cos phi and VRMS are along same direction. The product between these two is called as what? Average power. That means average power equal to VRMS into IRMS into cos phi, right? But in this, what about the IRMS sin phi? Product of voltage into current here we are getting, but we are taking the current only one component. What about the other component? This component cannot consume any current, then that component is called as wattless current, right? The formula for the wattless current is wattless current. In the power, right? In the power formula in AC circuit, only IRMS cos phi component of one current, okay, which is along the voltage, only consumes the power. What about the other current? This is IRMS sin phi, it cannot produce any current. Then the wattless current formula is IRMS sin phi. This is the formula for the wattless current. Wattless current. Okay, right. Till now, if you not subscribe my channel, subscribe and share to your friends. Thank you.